We're in the hydronic lab at BCIT in the piping department, and I'd like to spend some time showing you today some of the high efficiency appliances that we have and we use to instruct the gas fitting and plumbing apprentices at BCIT. Just to get started before we talk about the energy efficiency of these appliances, I'd just like to go over a brief overview how a standard traditional boiler works in terms of atmospheric firing with an atmospheric vent. Now what happens is when the boiler fires up, the gases ignite, they start heating up air. The air travels from underneath the boiler, goes up through the heat exchanger. The heat is lost to the median. Some of that heat has to be retained and heat up the stack. That is so that we have enough convection currents to keep that air moving and out of the building before it condenses. Yeah, unfortunately, what happens is that when that stack action can ill affect the burning process and cause it to burn with an unstable flame. So what we do is we install what they call a draft hood or a draft hood. This basically allows air to go up to the stack. When the stack gases are pulling and there's too much draft, the air will be put in through from the house. Okay, that keeps the burner and the combustion chamber at an atmospheric pressure, which is where it was designed. Now, it's these openings that cause the problem when we talk about energy efficiency. Inside a house, we've heated the air, we've heated the house up, and there's actually money in the energy that we have in there. When this boiler is not firing, there still will be convection currents causing air to come through these dilution openings and outside. That is a loss to the client. So what we want to do is prevent that. And we did that in around the 80s when we developed what we call a vent damper. I just wanted to show you the inside assembly. I'm just taking off the vent itself so that I can get at and show you the inside workings of these vent dampers. They're simply just a plate or a valve that goes across the area of the pipe. It's driven by a motor. This motor is connected to the actual control system in the boiler. Right now, this valve, or this butterfly valve damper, is open. That would allow vent gases to pass. It would also allow air to siphon up through their dilution air openings and therefore give us a heat loss. So this would be the position it'd be in when the boiler fires. When the boiler's finished and it's up to temperature, the motor will wind the valve closed, the damper closed, therefore blocking any further convection of the household air up to the outside. Here is an example of a radiant floor panel. It is a manufactured panel that would go down and replace your subfloor. As you can see that there's a spiral or a serpentine of coils. This is where we're actually going to put the heat from the boiler in, and this is going to cover the whole floor of your house. The interesting thing about this is it's an extremely comfortable type of heat, but in terms of an energy efficiency, we don't need very much temperature to get the heat into the room. So these would be very low temperature situations. We could run these at 100 degrees, maybe 110, and that would be enough to suffice and heat our homes. The deal with energy efficiency is that you don't want anything very hot because it's temperature that moves the energy from the inside of the house to the outside. So if you can keep your temperature differentials fairly close, you won't lose as much energy. And the advantage here is that we can heat a house at about 100 degrees boiler water temperature. Another example of how technology can reduce the energy consumption in a hot water heating system is to use an outdoor reset. This is a device that would actually go outside, and it's a temperature sensor. That temperature sensor could come back down to the mechanical room into your control panel and actually change the temperature of your water. Now what it's doing is indicating what is the heat load. The heat load comes from the outdoor air temperature, and it will adjust the temperature of your boiler water to exactly what is required to heat the system and keep you comfortable. In the lab, we've installed a high efficiency boiler that basically comes actually from the Burnaby area. What it does is it actually uses condensing technology to produce 10 to 15% more efficiency than a standard atmospheric boiler. It does that because it actually condenses the flue gases, regains the latent heat from that condensing, and then basically takes that to the two vents over on the other side. These are just plastic vents because instead of being 300, 400 degrees in traditional venting, we now can use a special plastic that is about 90 degrees. So you can see the difference in where the heat is. All of that energy has gone back into our system and stayed in the building. When you do condense the flue gases, you don't have to deal with the actual liquid. Underneath, you'll see at the bottom of this boiler, there will actually be a drain. That condensate will come through and it will go to drain. We've included a neutralizer here because that is not just water that's condensed out of the flue and from the combustion process. It's actually quite acidic, so we run it through just a neutralizer before it would go to the sewer. The other thing this boiler does that makes it extremely energy efficient is that it actually has variable input. The control system will tell this boiler how much heat is required, and the boiler itself can actually burn that much gas. So if I looked at the rating plate of this boiler, you would see that it has an input that might be only 15,000 BTUs all the way up to 120. And it would be the control systems triggered from the inputs to the control system. What is the load required at that given moment? This thing will ramp up and deliver that much energy. Again, we're not overheating anything. We're keeping everything quite low temperature as long as we can. Another piece of technology that we could look at that gives us energy efficiency is an indirect hot water tank. This tank's purpose is to store hot water for use in the domestic load. In other words, your showers and your kitchen. The energy efficiency comes because this is a well-insulated tank, but primarily it doesn't have a vent because it doesn't have a gas burner on the bottom. This tank receives its energy from the boiler. So what happens is the boiler water is fed to the coil in here. The coil releases its heat and heats up the domestic water. While we've been discussing how high efficiency appliances can reduce our cost for producing energy, it's important to realize that when we waste the energy before we use it, we are no farther ahead. This is an example of mechanical insulation. It's on a piping system. It could be made up of several different technologies. All it really means is that it is a material that has a very high R value. In other words, it does not conduct heat. In this particular case, when the heat that would be in, or the hot water would be in this pipe, it would stay in there because it would not be allowed to radiate or conduct out. In this form, we actually have now a PVC coating that will protect not only the insulation, but the pipe itself. At BCIT, we offer training for the heat and frost insulators. It's a Red Seal program, and these guys will learn to properly install this to make it as efficient as it can be. We've moved down to the shop area of Building Northeast 6, the piping department, and these four first units here along this wall represent the on-demand heaters that are available today. They are fully condensing, fully modulating units. These are the devices that you would install in your house to produce the hot water that you use for your showers and your bathrooms. If you're looking at the piping assembly underneath, please understand that this is a working lab that students use, and we can actually, this would not be installed normally, but we can put flow meters on, we can change the gas pressure, and we can do all sorts of labs to calculate just how these are working. So you would not see so much underneath as you are here. All four of these units basically will use the same recovery of latent heat that they get, that most condensing units do. That gives us that extra 10% efficiency, and it comes from the combustion process. The other interesting thing that these can do, and it's the newer technology, is again, we can change the input to these in terms of how much gas they're burning and how much heat they're producing. This would be any demand. So in the old days when we had on-demand heaters, if you opened up your tap, you would fire them, you would get a one-stage heat. And if you put too much water through your system, the temperature would just go down and down and down. So you had a minimum flow rate. Today, with the new technologies, as you open up more flow, these will actually ramp up the amount of gas they're burning and give you that set point temperature that you need. Here we have two condensing variable input boilers. They are placed in this configuration because they're actually heating the building that we're in right now. If we go over, we can see that there's a tank at the far side there that heats our domestic water, and we'll also pipe it into some fan coils that are in the annex and in the mezzanines of the building itself. One of the reasons that we place two boilers together is we can actually stage them. That means that instead of having one big boiler, we can put multiple boilers together, firing one or two as we need it, depending on the load. These boilers are so sophisticated that they actually will have in memory the actual firing time that they've had over the year, and it will come out equal by the end of the year. In that operating system in the NE6, we've actually got an indirect hot water tank that feeds all our washroom services in terms of domestic hot water. We also have lines coming up and going overhead. Those are going to the air coils that heat the offices for all the different rooms in the building itself. All of that is fed from our two boilers through a mechanical system that actually features smart pumps. These smart pumps actually have an ability to change their RPM and their power consumption based on demand that they need. So the computer control system could say that we only have to pump in so many gallons a minute, then they'll only pump so many gallons a minute. And you can see right now that this one here is only producing it's only going through about 6 watts of energy right now. It happens to be firing into the hot water tank. In this particular case, this operating and functioning system here is actually, all the information is fed back to our central heating boiler room at BCIT. The boilers themselves all have their own control systems in terms of firing, but all of this information of what this system is doing, what are the set temperatures and the cycling of the pumps, all that information is going back to our central heat. Here's another example of a boiler that is fully condensing and fully variable input. You can see that it has the fan that drives air from the source outside supply air, goes through a heat exchanger, and that's where it's lit off. It also has to have a condensation piping because it will fully condense the vent gases, therefore recovering all that latent heat that we normally lost a few decades ago. Another thing that we can do in terms of the flexibility of a hydronic heating is to look at different heat emitters. If we pan up top there, there's actually a air handling unit. It's a very small one for the residential, but here we'll put hot water to that, and then we'll drive heat through a heat exchanger, and we'll actually be able to heat up some air for any additional heat that we might require. This particular system also features the smart pumps that we can change in terms of how fast they go based on how much demand we need from them. Inside the shop, we have radiant heaters installed. These are a great technology for heating large spaces. If you're looking up top, you can see that the natural gas comes in through the gray box, and that fire goes all the way down the tube. So you're looking at a pass of flue gases and flame that would travel, in this case, probably 35 feet. When that tube itself gets hot, it will start radiating energy. We have a reflective reflector on top that will actually shine the radiant energy down on us. Now you remember that radiant energy does not heat the air, it's going to heat us when it heats the molecules. So we can actually get an example of piping and the cold tables here that actually will be warmed when they fire up. Great way to heat a large building. Here we have an example of a high efficiency furnace. This is a condensing combustion system. You can tell by the fact that it has plastic pipes for vents, and it has a condensate drain. So all the flue gases are going to be condensed, and we're going to recover the latent heat and put it back into our air. In this case here, we have a two-stage. It's not variable input. It is just a simple two-stage system that we can use, and if the first stage isn't firing well enough, then we can add more heat by just opening up yet another source of gas and going to a second input. One of the problems with the condensate, of course, it's coming out of these units by gravity, and sometimes we can't by gravity drain them because our drainage piping we're below it. So they offer just a simple little pump and reservoir. We can drop that in. There's a float in there. When the reservoir gets filled enough, it'll just open up a pump, and we can pump that to a higher source and out of the house. In a quest for more energy efficient appliance, the industry has developed a lot of sophistication in the control systems on these units. The standards for installations are controlled by regulations and good practices. The other side of the heating industry now will be, of course, learning how all these program logic controls work, how the internet connections work, all the communication skills, as well as all the different strategies that these guys can now put in their software. So there's a lot to know about these boilers from the commissioning point of view, as well as the installation point of view.